Hey everyone, welcome back to the channel. Today we're going to take a deep dive into AWS Elastic Container Service, or ECS, and set up a fully functional web server using Fargate. If you've ever wanted to deploy a containerized application without having to worry about managing the underlying servers, this is one of the best ways to do it. By the end of this video, you'll have a fully working Nginx container running in AWS, and you'll have a solid understanding of how ECS and Fargate work behind the scenes. So, before we jump into the AWS console, let's take a moment to understand what ECS actually is and why it's useful. Think of ECS as Amazon's fully managed container orchestration service. It allows you to deploy and manage Docker containers at scale. Now, there are two ways to run ECS. One is on EC2 instances, where you're responsible for provisioning and maintaining the infrastructure, and the other is using Fargate, which is a completely serverless option. In this tutorial, we're using Fargate because it eliminates the need to manage any servers. AWS takes care of everything, from provisioning to scaling, so we can focus entirely on deploying our application. Now, before we get into the setup, it's important to go over a few key concepts that will help you understand how ECS and Fargate work. First, there's the ECS cluster. An ECS cluster is simply a logical grouping of all your container resources. Within this cluster, we have tasks, which are essentially running containers. These tasks are based on something called a task definition. Think of a task definition as a blueprint that tells ECS exactly how to run your container. It specifies which Docker image to use, how much CPU and memory the container should get, the networking configuration, and other important settings. Then we have services, which are responsible for keeping tasks running. If you configure a service to maintain 2 or 3 tasks, ECS will automatically ensure that the specified number of containers are always running. If one fails, ECS will restart it to maintain uptime. Alright, now let's move into the AWS console and set everything up step by step. The first thing we need to do is create an ECS cluster. To do this, go to the AWS Management Console, navigate to the ECS dashboard, and click on Clusters in the left-hand menu. From there, click on Create Cluster. Now we need to give our cluster a name. I'll call mine My Cluster. Since we're using Fargate as our launch type, make sure to select Fargate here. For now, we'll leave everything else as default and click Create. That's it. Our cluster is now set up and ready to go. The next step is to create a task definition. This is where we define the container that we want ECS to run. In the left-hand menu, go to Task Definitions and click Create New Task Definition. Let's name it Nginx Task. And again, select Fargate as the launch type. Now let's add our container. Open a new tab and go to Amazon's public Elastic Container Registry at gallery.ecr.aws. This is a public repository where AWS maintains official images for commonly used applications. In the search bar, type Nginx and find the official Nginx image. Copy the image URI, go back to the AWS console, and paste it into the container image field. Now we need to name our container, so let's call it Nginx. We'll set the memory to 1 GB and the CPU to 0.5 virtual CPU, which is enough for a simple web server. Also, don't forget to configure the port mapping. Set it to 80, because Nginx listens on port 80 by default. Once everything is set, click Create, and our task definition is now ready. Now it's time to deploy our service. Go back to the ECS dashboard, select Clusters, then click on My Cluster. Now click Create Service. Choose Fargate as the launch type, select our Nginx task definition, and name the service My Service. Now let's set the number of tasks to 2. This means we'll have 2 running containers, which improves availability and ensures that if one container fails, ECS will automatically restart it. This helps keep our application running smoothly, even in case of failures. Next, we need to configure the networking settings. Select an existing VPC and make sure you choose subnets that allow internet access. This is extremely important because if your subnets are private, your container won't be reachable from the outside world. Now let's configure the security group. A security group acts as a virtual firewall that controls inbound and outbound traffic. We need to create a new security group that allows inbound traffic on port 80. This is critical because NNX serves HTTP traffic over port 80. Without this setting, users won't be able to access our web server. Once everything is set up, click Deploy, and AWS will start provisioning our container. This usually takes a minute or two. Now let's test our deployment. Go to the Tasks tab, click on the running task, and look for the public IP address assigned to our container. Copy this IP, open a new browser tab, and paste it into the address bar. If everything is set up correctly, you should see the default Nginx welcome page. This confirms that our containerized web server is successfully running on AWS ECS using Fargate. Now that we have our Nginx server up and running, let's talk about what's happening behind the scenes. When we create a Fargate task, AWS automatically provisions the compute resources required to run our container. Unlike the EC2 launch type, where we have to manage and scale virtual machines, Fargate abstracts away all that complexity. It handles server provisioning, scaling, and networking for us. Our container runs in an isolated environment inside our VPC, and since we configured a security group to allow traffic on port 80, users can access our application from anywhere on the internet. But what if we wanted to make this setup even more scalable? In a real-world scenario, you wouldn't want to run a single Nginx container without redundancy. Instead, you'd likely want multiple instances behind a load balancer for high availability. AWS provides an elastic load balancer, ELB, that we can attach to our ECS service. This ensures that traffic is evenly distributed across multiple containers, preventing a single point of failure. Additionally, we can set up auto-scaling so that when traffic increases, ECS automatically launches additional containers to handle the load. This is a best practice for running production-grade applications. If you're interested in learning how to integrate a load balancer and auto-scaling with ECS, let me know in the comments, and I'll make a follow-up video on that. Before we wrap up, it's important to clean up our resources to avoid unnecessary AWS charges. Go to the Tasks tab, select the running task, and click Stop to shut down our container. Then delete the My service and check Force Delete to ensure it's completely removed. Finally, go back to the Cluster section and delete My Cluster. This ensures that no resources are left running in our AWS account, preventing any unexpected costs. Alright, that's it for today's tutorial. If you found this video helpful, make sure to hit the like button and subscribe for more AWS content. Let me know in the comments if you'd like to see a tutorial on scaling containers with ECS, setting up a full CI/CD pipeline for automated deployments, or anything else related to AWS. Thanks for watching,